So what are the trends that I'm seeing and hearing about in the working world? And what does that have to do with Python and with data science? So I'll talk about who I view the current winners are. When I say current winners, I mean people who are keeping their jobs, who are getting more job offers, who are more likely to be up for some sort of promotion or the ability to manage a budget or manage a team, that sort of thing. So people who are succeeding in traditional economy. These days, they have three characteristics. The first one is they are very efficient. And so there's more and more stress on that concept, more and more emphasis on how efficient people are. And I can break efficiency down into first, an ability to automate repetitive tasks. So sort of like what I was talking about in the last video, if you can't automate tasks, then you're stuck doing them manually. When I say manually, I'm talking about things that people typically are doing on a computer, but doing themselves as opposed to programmatically, which means that some machine is doing it for them, and taking care of those tasks much more quickly. Second is an ability to reduce human error. So when you build software that does something for you, that software doesn't just typically do it faster if it's something that otherwise you have to do more than once, on your own. But also it's something that reduces human error. So after you built the software and once you know that it's working correctly, then from then on, it will do everything flawlessly in the way that you told it to, as long as it's a repetitive task. So those are two big points about efficiency. You reduce human error. You also speed things up when you move to programmatic deployment. And third, combining and eliminating workflows. So if you're building software that does things for you, you have the capacity to step back a little bit and look at how you can integrate with other kinds of software that maybe you built or that someone else built. And once things are more like integrated that way, then the whole process tends to get more smooth and have fewer steps in it. So that's the first category. The second one is data driven. And the first bullet point there is about capturing the right data. So people who are able to inform their decisions with data tend to do better today than ever before. So, okay, the first step there is you have to have the right kind of data that's relevant to whatever decision you're making. So are you capturing that, whether that's Internet of Things data or maybe data that was purely digital to begin with or some other type of data, whatever it is, whatever the use case is, that data being captured, then is it easily accessible? Is it stored somewhere where you can then access it so that you can then apply some kind of data science solution or data analysis method or statistical method? So I'm using that word modern data science method. A lot of the data science methods that are now very powerful in the working world are not actually, modern in the sense that they're not recent. They've maybe existed for a long time, but they haven't been accessible to the general public or to the average person just doing their work. But they are now. And so it's time to start using them because they're very powerful and they do great things. And they really do help us to make the best informed decisions that we can make. And that's very valuable when there's a lot at stake, when we're making decisions that have bigger consequences. So the third category here is versatility. So people who are not super set in doing things the way that they've been done, but instead are more willing to look around at what else is going on out there in the world that might be relevant, how they can learn about it, and then how they can use that to add value. So, for example, you're busy working and you're doing your work the same way that you've done it. It takes up all of your working brain energy and all of your time, versus you are automating your workflows. So you're earning back some time, which you then use to invest in exploring what else you can do and what other technologies are out there. And that's what sort of leads to step changes in how work is accomplished. And, you have to take some risk to try new things. but when those new things catch on and work, then they make a really big difference. So back to Python, and that we've kind of got that context of what sort of people are doing very well. What's Python good for? So Python, this is from the Python official documentation in 2020 year. So end of last year. Python is a high-level general purpose programming language that can be applied to many different classes of problems. So what does that mean? What is high-level general purpose mean? So there's a spectrum of programming languages. There are low-level languages and there are high-level languages. So low-level languages, those are languages where you don't just tell the machine, hey, I want to do something. You have to tell it how you want it to handle each of your instructions. So for example, please use this operating system. Please use this processor on my computer. Please store the temporary data in this specific location on the computer, as opposed to just being like, I want you to do this command. I don't care where you store it. I don't care which processor you use. You make the decision, make sure it's the fastest one, whatever. So the low level languages, there's a lot more to kind of specify, and it gives you a lot more control. The code has major dependency on the outside structures and services. So for example, if you don't have that operating system installed, or if there's a slightly different name for the processor, then your whole code could kind of fall apart and crash. So high level languages, by contrast, you kind of just give the machine the high level, that's where the term comes from, the overview of what you want it to do, and then you leave the how up to the machine. So I want you to go through each piece of data in this data set and do the same thing to each piece and change it around and then save it in a new format. That would be the kind of command you could give to a high level programming language versus a low level. You have to tell it a lot more about how you want it to do each of those things. So the high level languages, those languages, the code that you create with them have less dependency on outside structures and services. So typically what this amounts to is, for low level languages, they're quicker for machines to execute, because once you've actually written the code and you tell it what to do, it's having to do less exploration about, well, I could do things this way, I could do things this way. Let me see which one's better. Let me try one, and maybe it was a slower way. If you just tell it exactly what you want it to do, it just does exactly that. There's less overhead when interpreting human generated code. So that overhead means running various other processes in the background to make sure that the options for how you can execute things in a high level language context are available. So the actual process of running the code is using less of your memory, so that more can be diverted to actually doing what the code tells the computer to do. Low-level languages are more likely to do something on a machine level, like maybe sound a buzzer or vary an engine speed or something like that. And their associated files are smaller. So when you save the file, they're smaller. And that has to do with that overhead thing too. There's less sort of metadata or behind the scenes data that has to be stored along with the low-level language code. So it's all right there in the code. The high-level stuff, by contrast, much easier for humans to learn, because you're just focusing on the strict logic and less about how the machine is storing things and where and so on. It's easier for humans to find and troubleshoot problems, because the code is more kind of tailored to just that logic. High-level languages are more likely to do something on a human interaction level, like render a web page or interpret some sort of user input to a program. And the associated files are bigger, but typically much more versatile. Okay, so that's the low-level, high-level language stuff. Python is a high-level language, so it checks all these boxes. What's interesting though about Python is that it's still really fast to execute. When I say really fast, I'm talking about objectively. Comparatively, depending on what you're doing, something else might be a better choice if you're going for pure speed. But that's starting to matter less, as we'll see, because processors are just getting so much faster that, a quarter of a second versus half a second is like a 2x, increase in time, but it's such a small quantity overall that by the time the human has hit enter and moved their finger to hit the next mouse, you're already done. So it doesn't really matter that it's twice as slow. Really interesting what that does to change the relevancy of Python even reaching into territory that used to be more just exclusively low level. Similarly, Python has this pretty good way of optimizing the execution, which to me seems sometimes to be just downright magical. So, Python, please do this for me. And then, wow, it did it very, very quickly. I don't know how it did it so quickly. I didn't tell it to do things in the way that I thought was going to be the most optimized, but it kind of figured out how behind the scenes to leverage what it had available to do things very quickly. So that's great. Another thing is that Python can interact very well with different kinds of machines. And so you can actually get Python code that will do things like sound a buzzer or vary an engine speed, or sort of interacting with other kinds of software or hardware is not sort of outside the range of what Python can accomplish. And it tends to be pretty nice and compact. So when you store files, they're not too huge. So wow, kind of a nice language, right? It's definitely a high level language, but it does okay across the things that normally only a low level language could do. So that versatility makes it really popular. So this pypi.org is a place where you can go to see a whole bunch of different Python packages that the open source community of developers have created and released. And there's a huge amount here. So you see there's like 2 million or so releases, and this was sometime last year in 2020 when I took this screenshot, across an eighth as many or so projects. So lots and lots of files to look at and lots of users contributing. And, how many people are using Python? They don't keep track. Python doesn't keep track directly of how many people are using it because it's just a language, and so it can be used in a lot of different contexts, and they're not necessarily trying to control it. And the they that I talk about isn't like, a strictly defined organization. It's just something that is happening, like more of a movement. Free to download as well, so it's not really tracked very well. But it's certainly taking off. And one way you can tell it's taking off is by going to websites where people ask each other questions about how to get stuff done in their scripting languages. So one of those websites that's super popular is Stack Overflow. And they released this information, I think, in 2018 about what happened over the course of 2017. And all the way back to 2012, it looks like. So we see Python, the number of questions that people were posting into the forums on Stack Overflow about Python, it was the lowest, it was just underneath C++. And then it sort of surpassed C++, and then it continued to grow all the way up until it surpassed everything else. And notice that some of these other things, in particular Java, which has kind of gone up and down, went down as Python went up a little bit there. So perhaps some people are sort of switching to using Python away from other stuff. JavaScript continues to be really popular, but look at that, Python is sort of emerging as the top and has enjoyed immense growth recently. So, okay, lots of people are using Python if this is a proxy. Here's another way to break it down. This is traffic by industry to Python, also Stack Overflow, released around the same time. I said 2017, data released 2018. Maybe this was actually released in 2017, but yeah, it looks that way. About 2017 and earlier. But so I think the trend has only accelerated since then, but this is still pretty relevant data. So we're seeing that this is percent of 2016 traffic going to Python, percent of 2017 traffic going to Python. So everything that's over here, has enjoyed an increase. So it's all increasing. And then we see the different sizes of the dots correspond to their percentage of that traffic. So a lot of it was academic, but more and more growing in the tech scene. And by tech people, I suppose I should say software people, when they use the word tech, they use it to mean software. And so a lot of software stuff that publishes about software calls themselves tech, which is kind of arrogant because there's a lot of other tech, like the chemicals industry is new technology as well, but that's not traditionally called tech. But anyway, so the software industry here, has seen a lot of growth. Manufacturing as well, government, finance, energy. There's a tiny dot there, kind of hidden underneath finance. But yeah, so lots of growth in Python. Another thing to talk about here is that data science is enjoying a very popular resurgence. So data science as a field had gone rather academic for a while. And then two things are starting to change that. Two things have been changing that, in fact, over the last few years to make it very relevant to firms everywhere. So the first is an increase in computing power. And the second is an increase in the availability of data. So let's explore this first one first. Here's a very busy slide. This is dealing with Moore's law. And Moore's law, this guy made this prediction a while ago that the number of transistors on an integrated circuit chip every 2 years will double. So that's why you've got a log scale here, and then you've got a nice linear scale here. So every 2 years, we should expect a 2x increase. So it's compounding. It's growing very, very quickly. So how many transistors can you fit on a chip? Back in 1970, you could fit between 1 and 5,000. And now you can fit between 10 billion and 50 billion. So pretty impressive what a computer can do now as compared to what it could do when computers were brand new. And what that means is that, the kinds of stuff that was only possible to do when exploring data statistically on a computer, like that kind of stuff that's super handy and fancy, was only available to people who had access to super powerful computers back in the day. They were really, really expensive. Computers that had so many transistors in them and amazing cooling systems, and getting some timeshare on that computer would be a really, really big deal for somebody in academia. Now you can just do that on any old laptop you buy, right there on the hard drive. And it might have more than one processor in it. So, you devote one to one thing and one to another thing, and it's just really quite quick to do something that used to be quite, from a processing standpoint, quite expensive. And the other thing is that you don't even need to use your own computer to do that processing. You can just, borrow or rent a computer from a service provider, whether it's Amazon or Google or one of those other giant companies that does this sort of thing and has kind of cornered that market. So then you can get your work done on those kinds of computers that are being communicated with using the internet rather than your own computer and your own computer's hard drive. So, okay, cool. So there's kind of this, it's been a bit democratized, and it's given people access to use these data science methods that used to be sort of off limits. But then in addition, there's just a lot more available data to use. The amount of data that's just out there is growing so fast, and it's being stored. So that means it can be accessed. It means that you can access it yourself and extract value from it, whether it's your own firm's data or data sets that are publicly available. So the International Data Corporation, the IDC, releases a bunch of information about what's happening with data. So in 2018, they said that the amount of data would grow 5.3x by 2025, from 33 to 175 zettabytes, or billions of terabytes. A megabyte, you go from megabyte, 1,000x is a gigabyte, 1,000x is a terabyte. And then if you went up 3 more thousands, in other words, 9 more zeros, then you'd get to zettabytes. So we're talking about quite a lot of data overall. So, okay, so there's more data, but more of that more data is now available to people. So the same group, the IDC, International Data Corporation, in 2018, predicted that 49% of the data would be stored in public cloud environments by then, with nearly 30% of the data analyzed in real time. Okay, so stuff is just out there, and it's going to be accessed really quickly and evaluated really quickly. So here is 2015 and 2016 from D-Zone, reported in 2017, showing what are the tools that people were using for data science. So just general survey, asked a ton of people, if you're doing data science work, what tools are you using? And we see R here at the top, both in 2015 and in 2016, but Python grew a huge amount from 2015 to 2016. And notice that if we add all these lines together, then we get more than 100% for any given year. That's because people use more than one tool. Organizations use more than one tool, depending on whether they're asking people or organizations. But it's a pretty big sample size, I think. And so we see a growth in Python there. And then different group, but similar survey, data science tools by popularity from 2017 to 2019, published at the end of 2019. So we have green 2017, red 2018, and blue 2019. We see Python continuing to grow and then just kind of get up there to the top and stay up there at the top, and that's continued to be true. So Python is a language of choice for data scientists, and it's a language of choice for a lot of different types of problem solvers, but in particular, it's really stood out in the data science world. And that's because there are a lot of tools in Python that really allow it to handle data very quickly and to come up with really valuable and meaningful insights from that data that otherwise would be like pretty hard to gather from these other tools. All right, so coming back to what it takes to be a winner in the contemporary economy. Now that we've talked about Python, let's kind of combine these things. So the efficient qualifier, if you want to be really efficient, then what can Python do? Well, Python can help you to learn. You can learn Python really quickly, and then you can execute it really quickly to apply it to automating your repetitive tasks. So you learn Python, you get up to speed to the point where you have this nice sort of foundational knowledge. And then you can just reach out there and grab the things you need to cobble together something that automates one of your workflows. You verify that it works, and then from then on, you use it again and again and again. And it always works for you the same way. You can also debug and test your code easily, so that human error can be a problem in coding, because if you don't realize that your code has a bug, that would be your human error. Then the code can perform in a way that you didn't want it to, and can continue to just make the error again and again, right? But it's not that hard to tell what's happening behind the scenes with Python, and how it's getting done, what it's getting done, and what's being stored, where along the way as you're executing. So a lot of the developer environments for Python are just really, really easy to use. So you can really be sure that things work well before you start deploying them on your actual work and relying on them, taking them for granted as they're automating things for you. And then you can share it very safely. So even though Python is open source and online, it's a pretty safe language. It's something by the time it's published and generally used, and there's such a huge community that if somebody tried to do something malicious in Python, it'd be extremely, extremely tough to get away with it, because so many people are using it and policing it. So one person would have to contribute something that fools a humongous number of users in order to get away with doing something malicious. And that's kind of the self-policing open source community thing. But you don't even have to, it's not like everything that you make in Python is instantly published online and everyone has access or something. It's, you run a little local a version right there on your computer, and nothing gets shared. And if you borrow somebody else's code and you use it on your local computer, you can unplug it from the internet and turn off your Wi-Fi, and just use it and get stuff done. So, it's not gonna just the fact that it was developed by a community that didn't get paid to develop it doesn't mean that it's more inherently risky. So you can share information and code, safely. You can strip the information from the code and share the code safely. You can download it and know that what you're downloading only contains what you wanted to download. You can cut and paste that into your scripts and combine them and make them do interesting new things to help you get your work done even better. So it's really nice to have that open source community with a lot of things going for it, backing up what you're trying to do with Python. So when it comes to being data driven, when you want to capture the right kind of data, however you need to capture it because of what it is, maybe it's IoT data and it's captured in like a CSV, or maybe it's user feedback data and it's captured on a website or whatever it is, Python can read it. Almost almost any type of data, almost anywhere. There's some sort of library that will allow Python to import it and turn it into a type that then is very easily manipulated inside of Python. It's also pretty easy to visualize and clean data once it's in Python. So once it's accessed, you can manipulate it and organize it and get it set up so that you can then apply data science methods very easily. In fact, I think it's so easy to do fancy data science in Python that it's rather dangerous because people might be tempted to use methods that they don't understand. So there are a lot of courses that teach data science on either end of a spectrum. Some courses teach data science in a way that is like extremely practical and they don't cover any of the theory. And it's just like, here is a method, here's the tool in Python, you click train, you click execute, here's your output, use that to make your decision and you're done. And that is kind of dangerous because it really is that easy. Then there are courses that, are less courses and more like, a PhD or something where you spend a huge amount of time and you go into all of the detail about how each of these various methods works. And, I think that because that's so hard and takes so much time, most people kind of err on the side of just going for the really easy stuff and then being like, hey, I'm a data scientist. I know they're in high demand, hire me. And really something in the middle is sort of needed. So that's the gap we're trying to fill with data science training. But anyway, Python makes that possible. You can do things super easily. You can spend a bit more time to understand what's happening inside the black boxes to allow things to inform your decisions very easily. Or you can really go into a huge amount of depth over a long period of time and really learn it thoroughly, catch up and be super cutting edge about it. Able to contribute to the cutting edge rather than just sort of use it effectively. All right, and then there's the versatility component. So what else is going on? If you want to learn what else is going on when it comes to Python, it's pretty use case agnostic. So it's not a tool that was built to solve just one particular problem. And we saw that in the definition provided on the Python website at the beginning of this talk here. So it's generally applicable. However, there are lots of libraries that are built and shared with Python that do very specific things. So if you're in a really specific kind of industry doing a very specific kind of job, chances are there's not one, but several different libraries that are being updated, as we speak, that are relevant to your work. And knowing what they are and maybe starting to learn about them and maybe even contribute to them is not a bad idea because they're probably going to change how your job is done, and staying on, riding that wave is a good idea so you don't get left behind. Also, it's free. So I'll end there. Thanks for listening, and I'll check this video periodically. So if you put questions in there, then I'll try my best to hop on and answer them.